Hi, everybody. Here we are, week two. And again, what you're going to find is that Alex is, uh, again, taking that approach that's more or less self-paced or guided, whichever what term you want to use. Um, so it's going to be a little bit different for everybody. But the main theme this week is probability. And what I kind of have here is kind of I don't know, a little cheesy, I guess, if you will, but I think it's a good analogy here where you have a house that's built here, and it doesn't look like one, but what we're actually doing is we're going to take a look at probability theory. Now, the frustrating part of this is that most of the exercises are going to be kind of disjoint all over the place, different types of problems to illustrate a couple main principles and probability that we're going to be using. But where this fits in actually is the foundation of practical solutions, which I guess is the roof of our house. And so what leads us to that is inferential statistics, which we're going to really delve into week four. We're really going to, start getting into these two processes or methods that's basically used, and that is estimation in terms of estimating parameters. That would be, things like population means and population proportions and so forth based on sample results. And then also something called hypothesis testing, where again, the data that we collect either by sampling or by experiments, we can see down here this data production. And again, it's very important that this is, done properly in order to get solutions here that are meaningful. Okay, so these are the two techniques we're going to use. So, really how this all fits in, this is the foundation probability theory. And then from that, that first level, what we're going to deal with, and we've already talked about, was data production. And, essentially whether you're sampling or using experiments here, I forgot my period after the two. But what you're doing is you're setting the stage in order for probability theory to apply. In other words, these data here, provided that we use chance to select them, we're going to end up with something that's going to be representative of the entire population in the long run. Okay, not always, but more than likely. From that, we take these data and summarize them, and whether we're using graphs and these statistics here, and we'll take these statistics, something like a sample mean, and use it to estimate a population mean. So, this is kind of the ground level where all this stuff kind of comes together. And once we get this established here in weeks 1 through 3, what we're going to do is it's going to lead us into now applying that and then ultimately leading us to practical solutions. So that's kind of how all this stuff fits together. So if we get into the probability part of this, what I want to keep in mind is that it's going to be tough. These problems are often counterintuitive, and it's going to seem like that they're just so far off in some instances. In others, there are practical probability problems just in themselves, but not quite in the way we're going to ultimately use them. But again, a lot of times these results we're going to get are counterintuitive, and you're going to be frustrating, and it's just going to take some time. And so all this stuff right here is what you're going to be dealing with. And it's just going to seem sometimes overwhelming to some people. Now, other people, they kind of tend to pick up on it quickly. I could tell you from my experience in the past, it's just, I'm one of those people, it just takes time for me to work through stuff. And I can remember being very frustrated, working some of these probability problems. But ultimately, we want to get to this point right here where it's the foundation for the inferential statistics that we're going to, and methodology that we're going to be studying. Essentially, there's three different ways of looking at probability. One is a classical probability. In essence, what we're doing is using a sample space, which is basically, you'll see in the readings and the problems, it's just a list of all the possible outcomes, and we can determine the probability of an event would happen. And so, they give you an example like this, for instance, when a single die is rolled, and there's six outcomes and each outcome has a probability, right? As long as they're each equally likely to occur, probability of getting like a four is one out of the six. So we look at it as a ratio or a proportion right here, and they give you another one with a card example. But this is kind of the classical probability method, that we're probably all familiar with, the coin 50-50 shot and that sort of thing, 50-50 heads and tails. The empirical probability is kind of we're probably going to be focused more in this realm here, although we will, at times look at classical probability and their, applications. It's really here that what we're going to kind of look at is, and that is, when we do something over and over and over and over and over again, what we're going to do is just observe the frequencies. And a lot of times these probabilities are, determined by something called a simulation, which I'll probably refer to and maybe even illustrate as we go through. And that is, it's just some sort of scenario that mimics some sort of real life instance here or situation. And all we do is just keep track of how many people or things or how many outcomes happen relative to the total number of times we, repeat that type of experiment. So if we look at it, an experiment of rolling a die and we roll it 6,000 times, and we look at, how many times does a 1, 2, 3, 4, 5, 6 come up? And we should see that it's about, all those should be about 1/6 of 6,000, or let's just say, easy mathematically, right? We should get 1,000 of each. Although we might not get that exactly, we should be pretty darn close to that. And that's what empirical probability is. It's just the percentage of times something comes up, right? If we take 1,000 divided by 6,000, we would get that theoretical probability of 1/6. So, here we're going to, look at just another example where they ask 50 people, excuse me, who are traveling over Thanksgiving, how they'll get to their destination. And you can see that, if these people are relative, or do represent the population that we're seeking of all travelers, then what we could say is, well, if I select one single person from that population, then the probability is going to be, approximately 3 out of 50, whatever percentage that's going to be, which would be about 6%, right? Or 6 out of 50, which would be 12% would fly, or 82%, right? That would be 41 divided by 50 would be 82%. So we would say there's an 82% chance of selecting somebody that would fly, 12% selecting somebody that would fly, or a 6% chance of getting somebody who would take the train or a bus. And, obviously, if we asked a different 50 people, we would get slightly different results. But in the long run, we should get pretty much settling in on some proportion or ratio. Now, 50 isn't a lot when you're dealing with empirical probabilities. Usually we deal with, things in the thousands, hundreds and thousands, and so forth. And that's why we use computer simulations to go ahead and do that. But anyway, that's just, I don't want to get too much in the weeds of this. So that's just another way of looking at empirical probability, which is kind of what we're going to really focus mainly on in terms once we start applying probability problems to inferential statistics. And then there's this subjective probability, which really, honestly, this is the first textbook I've seen that included this, but, there'd be some sort of educated guess or estimate. And, it might be some announcer saying, well, there's a 50% chance that, the Steelers are going to win the Super Bowl this year or something like that. And, they give some other examples down here, doing that. And it would be, again, some sort of, expert in the subject. And so, but again, it's completely subjective. There's no theory to it. And, but a lot of times we use the term probability when dealing with something like that. And we're not going to work that much or at all with this, but I just thought, I would include it because your textbook does. And, okay, so that's pretty much it, what I wanted to do here to introduce this to you. Again, The bulk of the material you'll see, I'll have additional videos of it, examples, because that's what you're going to get bogged down to. And the problems are going to seem very disjoint all over the place, no rhyme or reason. We can kind of generally group them into different types of problems, but overall, it's just going to take a little bit of fussing and sitting down and, just struggling to get through the material. And it's just an unfortunate part of statistics course. Ultimately, we do get a decent amount of benefit from it because we'll refer back to similar problems, once we start dealing with applications of concepts and so forth in the future. So just kind of hang in there, and we'll see how it goes. And be sure to always ask questions if you need to. So, all right, we'll talking to you in the other videos here coming up.